and dry. It's climate!
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
Bill.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Cold and Wet, and by Hot and Dry.
Whew! How's the climate where you are? It's nice in here. It's warm. Now, the Earth has many, many different climates. Some places, it's hot and dry. In other places, it rains a lot. Now, how warm or wet a place is overall is what we call a place's climate. The Earth has hundreds of them. Take a look at this. This is the Earth Climatological Model of Science. Well, it's a picture of the Earth. And you can see that the Earth is covered mostly with water. Mostly with water. Now, the energy of the sun's rays beating down all the time makes the water in the oceans and rivers, lakes, and streams end up in the air, in the atmosphere. And the movement of the atmosphere makes that moisture move all over the world and creates all these different climates. Now, different kinds of living things have found ways to live in every climate on Earth. And it's all because energy from the sun makes water end up in the atmosphere, in the Earth's air. No matter how warm, wet, cold, or dry, climates all start in the sky. It's a poem.
It's time once again to search out weird weather wonders from around the world. Join us in Climate You Find It. Dateline, Kansas. Tornadoes touch down on the Kansas plain. Warm, humid air from the Gulf of Mexico and cold, dry air from the northern plains collide over the flat Midwest. The result is a new twist on the old theme. Climate is affected by location.
Climate is how warm or wet a place is. See, this is a pretty dry climate. But with a little moisture, things will still grow here. It's fascinating.
Climate is how warm and wet a place is overall. Some places are wetter than others.
Wish it was wet out? We'll make some rain. Take a 2-liter pop bottle like this and cut it so it sits like this.
Now pour some very hot water into the lower part of the bottle. This is some very hot water.
Very hot. Go. Now put some blue food coloring in. Add some blue food coloring.
What?
For effect, put in some blue food coloring.
What?
Because, you know, kids love that blue food coloring. Right, Jafar?
Yeah.
I've grown out of it.
That's right.
Put the lid back on and add a couple cubes of ice.
Look, there's a cloud forming inside. Little droplets are forming on the outside of the bottle, and especially on this icy top. Now, why is that?
Because condensation.
See, what's happening is the water is evaporating from down here. It goes up to the icy part and condenses. It turns back into liquid water the same way raindrops form in clouds. And then it falls down, just like rain. Now, Jafar, let me ask you something. Why is the blue color staying down here but not ending up in those little droplets?
I don't know. You're the science guy.
A light-colored cotton turban and flowing robe help keep the sun's hot rays off this desert dweller during the day, while at night it keeps the heat in. This cactus cutie also has just the right equipment for desert living. Holds water well, has a prickly outside to keep thirsty creatures out. Desert fashions, they're always hot.
Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale. and the one at the South Pole is right around the room temperature mark. And the ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on, whereas at the poles, it's just barely grazing by. And then somewhere in between, well, it's somewhere in between. You see, it's not that the equator is closer to the heat, it's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp just barely grazes by. I mean the energy from the sun. Well, anyway, thank you for joining me.
I can think of a few climates. Let's see, there are ice caps, tundra, taiga, temperate deciduous forest, temperate coniferous forest, temperate rainforest, tropical rainforest, Mediterranean, grassland, prairie, savanna, steppe, desert. I know there's more, but I'm cold. I need a warmer climate.
Mountains have a big effect on climates because mountains are big. See, when air comes in from the ocean this way, it'll hit mountains like the Sierra Nevadas, or the Cascades. And when that happens, the air goes uphill. Now, when air goes uphill, it spreads out because there's less pressure above it pushing down. Now, when air molecules spread out, their energy spreads out, and the air cools off. When that happens, it starts to rain or snow. That's why there's snow in the mountains. This is especially true of big mountains, like the Rockies in the middle of the United States. See, when air comes over the Rockies, it loses a lot of moisture. Now, moisture that falls on this side of the Rockies goes that way to the Pacific Ocean. And moisture that falls on this side goes that way toward the Atlantic Ocean. It's a continental divide. It divides the continent into two giant climate systems. The reason it has such a big effect on climates is because mountains are so big. Whoa!
Dateline, India. The monsoons bring torrential rains to southern Asia. The hot Asian sun heats the land surfaces more than the sea. Hot, dry air over the land is pushed out of the way by warm, humid air from the Indian Ocean.
This is a rainforest. Now, rainforests are home to more than half of the plant and animal species in the world. In fact, this fern plant is only found here in this rainforest in Hawaii. Now, a rainforest is a climate that's warm and wet. It's great for growing things. It's a beautiful climate.
Hi, I'm Nana Zolbrod. I look at how climate change might affect the distribution of plants across the landscape. Plants grow through temperature and precipitation. As these factors change, then the ability of plants to grow effectively in a certain area will change. We already have signs that the climate in the past 100 years or so has warmed quite a bit. We can see this from little tree seedlings like this invading meadows at the edge of forests, where before trees couldn't grow because it was too cold. This is a great big old fir tree that grows near mountaintops, and it should have a good long record of past climate changes, because if it was a warm year, say, it may grow a lot more than if it was a colder year. Now I'm coring the tree in order to get the record of the rings. This doesn't hurt the tree at all. You can just see the bark coming out now. These are pieces of the core that we just pulled out from the tree. It's a slice of the cross-section of the tree. Trees grow from inside to out, and so each ring represents a year's growth. There are some years in which the tree grew really fast, where you have fat rings, and then some years where you have skinny rings, where it grew more slowly. So the more we understand about how climate change affects the world around us, the more we'll be able to respond and keep our forests growing healthy, keep the species intact. It's really important to study climate change effects.
Hi there, I'm Bob, and welcome to This Old Climate. Let's come on down here. Watch out for that hoe there, Tom. Here's Heidi down here working on the A-frame.
Hi, Bob.
Oh, hi, Heidi. This is coming along nicely. The A-frame's going to be perfect for the wet and snowy Swiss climate.
Ja, the A-frame will help in the snow and falling off in the roofing.
Ja.
Ja.
So, Heidi, to demonstrate how this works is, as snow falls, you notice it doesn't accumulate up on top of the roof. It goes down the sides of the roof and onto the ground so your roof doesn't cave in. Very smart.
Ja, ik ben een smarte huisbeelden. Ja.
You enjoying that, Heidi? See, it's going right down the roof.
Right down.
Right on down the roof.
To the floor.
Climate is how warm and wet a place is. So it's true of small places like islands. It's also true of micro places like the side of this tree. See, the moss grows on the north side where it's cooler and wetter. But where the sun shines brightly, the moss doesn't grow so well. This is a microclimate. They're everywhere. See this tree? All the roots are exposed. And look at all the stuff growing on it. So you don't find a tree like this just anywhere. No, you find a tree like this in the tropics, where the climate is warm and wet. Wet, see?
Like, why would I want to live anywhere but the tropical rainforest? It's like so warm and wet, and like, that's the only place I'd want to be because it's like the perfect climate. Tell me that Tiffany has such an attitude about latitude. It's like, I just want to say, chill, polar ice cap girl, okay? If you want to live in a cold, dry climate, that's okay with me. But you don't have to be so frosty to all your friends.
What's in the atmosphere helps control our climates. Take a look at this. Take a look at this. Take a look at this. It's our atmospheric warming tank of science. Now, on this side, we have nothing but regular air. But on this side, there's almost nothing but carbon dioxide. Carbon dioxide. Carbon dioxide. Here, I'll show you. If I take a match, let it burn, it burns fine in air. But in carbon dioxide, CO2, it goes right out. Carbon dioxide puts it out, just like water. Now, carbon dioxide is heavier than air, so it stays in this side of the tank. Now, take a look at the thermometers. The one on the air side is reading around 20 degrees Celsius. But the one on the carbon dioxide side is reading a little bit higher, just a few degrees warmer. That's because carbon dioxide is a gas that helps hold in heat. So carbon dioxide in the world's atmosphere helps keep the world warm. It holds in heat. Without it, the world would be freezing cold. Here's the thing. Right now, we're pumping billions of extra tons of extra carbon dioxide into the world's atmosphere every year. Billions of tons of it every year. It comes from cars, trains, and planes. It also comes from forest fires. People are burning down forests to make room for farms. But here's the thing. If the world gets a little bit too warm, then the level of the oceans may change, and the world's climates may change just a little bit. Just enough to make it impossible for us to grow enough food for everybody to eat. So we need some carbon dioxide in the atmosphere, but not too much. Now, this process of extra carbon dioxide and extra other gases in the world's atmosphere is part of what we call global warming. Global warming. The globe is getting too warm, and something we've got to be careful of. Otherwise, things could get weird.
Igloo Dollhouse, the latest in climate-controlled kiddie fun. That's right. For just $29.95, you can own this Igloo construction kit. Just add water, stick in the freezer overnight, and come morning, you'll have all the parts to make an Igloo Dollhouse. Some assembly required.
Igloo! Steve Poole joins us now. We've had a lot of changes around here in our weather, and this time it looks like it's going to get even colder.
Yeah, a little bit more cold, so now we have to watch things a bit more closely. Now, I want to emphasize here that we're not talking about a concern for all of you, or even that big a concern, but it's something worth mentioning, so let's do it. It is much more difficult to do the weather than it is to put a man on the moon. The math is much more complex, which kind of explains why we blow it sometimes. Maybe one way to think of it is think of the atmosphere as being like a river. only it's a river of air instead of a river of water. And it's constantly flowing, right? And we have these areas where you have higher pressure and lower pressure, and all of these things are moving. And as it moves across the globe, it changes the weather for everybody. So you may have a certain climate in your area, so you're, like if you're in the desert, it's probably more dry there. If you're in the Northwest, it's probably more wet there. But overall, you keep getting change because that river of air is constantly in motion. It's obviously important that I know about the weather in just my community that I forecast for, but you also have to know about the entire country and the entire world because it's all linked together. Nothing happens here where it doesn't have an effect someplace else, so you have to be aware of that. All of the climates are linked together. You can't separate them.
I was right. A climate is how warm or wet a place is. Now, right now, it's not too warm, but it is pretty wet. There's snow all over the place. But these trees, and the other animals and plants that live around them, are well adapted to this climate. They've been here for millions of years. It's a temperate rainforest in the mountains. It snows all the time, it rains all the time, and everything that lives here is used to it. Isn't it beautiful? Woo!
It's cold and wet. Got it? You're in the temperate forest, where winter means cold and wet. Rain falls year-round. Some trees lose their leaves. There's snow and wind and...
No forest here. It's a desert.
The reason scientists release weather balloons is so they can find out more about the climates. This instrument will measure wind, humidity, temperature,
and pressure. When this thing gets up to about 100,000 feet, this thing will explode and this will drop.
The radio sign. And when the balloon pops its parachute, it brings this radio sign down. These instructions are for the person who finds it, and so they read it so they can return it. Let it go!
It's way up there.
In this climate, it's hot and dry. Doesn't rain very much. So the only living things you find around here are living things that can get by without much water, like this cactus. Ow! Ooh! Doc, got it.
Dateline.
Climate determines the kinds of plants and animals that live in different places and how they live, like cacti in the desert.
The ocean has a big effect on climates. In Britain, it doesn't snow very much, all winter. But in Nebraska, it snows all the time. That's where we have blizzards. Now, why is that? That's because Britain is kept warm by an ocean current called the Gulf Stream. Now, the water is too cold to swim in, but it's plenty warm enough to keep the climate of Britain much warmer than it would be otherwise. And in Nebraska, we like to say, there's nothing between you and the North Pole but a barbed wire fence. And even that's blown down. Ha! Sorry. In South America, every year in the winter time, there's an effect called El Niño. El Niño. Where the surface of the Pacific Ocean gets a little warmer than it seems to be otherwise. This has a great effect on climates. It changes the rainfall and how warm or cold it is in South America. And in North America, El Niño affects how mild or tough the winters are. Now, El Niño means the little one. But it has a big effect on climates. That's because the oceans are big. Oh. Whoa.
Amid a land of great ice lies the strangest desert in the world. 300-kilometer-an-hour winds and temperatures 70 degrees below zero make the dry valleys of Antarctica one of the most inhospitable places on Earth.
Places that are very, very dry often have climates that are called deserts. Places like the North and South Pole, where the temperature hovers around 30 below 0 Celsius all the time. The snow there never melts. Sometimes snow will stay there for centuries, even though it snows very, very little every year. There's very, very little precipitation, so the North and South Pole are deserts. Bitterly cold deserts. Did we get it?
Mm-hmm.
We get it? Ran it. Fabulous. All right. I got stuff to do. I'll be in one of my trailers.
Whether the weather is hot or whether the weather is cold, there's just one thing you need to be told. Whether the weather is hot or whether the weather is cold, there's just one thing you need to be told. Climates are different all around the world. They affect every plant, animal, boy, and girl. Now out in the desert there's not too much rain, but the temperature can vary enough to make it insane. And there aren't gonna be too many storms coming by. That's cause the deserts are warm and dry. Tropical rainforests, I'll tell you later, they can get pretty hot. They're usually near the equator, and it rains really hard, on that you can bet. Tropical rainforests are warm and wet. Climates are different all around the world. They affect every plant, animal, boy, and girl. Near the North and South Poles where it's really cold, there's a place called the tundra, or so I'm told. And hardly any rain or snow comes from the sky, so you see that the tundras are cold and dry. The temperate forest is a pretty cool place where a low temperature is often the case, and it rains quite a bit, so if you don't know yet, temperate forests are cold and wet. Climates are different all around the world. They affect every plant, animal, boy, and girl. Whether the weather is hot or whether the weather is cold, there's just one thing you need to be told. Whether the weather is hot or whether the weather is cold, there's just one thing you need to be told. Climates are different all around the world. They affect every plant, animal, boy, and girl.
Love that song. Well, that's our show. Thanks for watching. If you'll excuse me, I've got some atmospheric gravity waves to monitor. See ya.
Produced in association with the National Science Foundation. Whoops, watch it.
What's in the air helps control our climates. Take a look at this. It's our atmospheric... Take a look at this. It's our atmospheric global warming. No, atmospheric warming. Sorry, my mistake. Oh, and he's sliding down the pole. I'm sorry. Fire! Volcano snakes! Oh! El Nino! Oh!
You don't happen to have